Watch this actual footage from a flash flood in Los Angeles. See how quickly the water rises? Now imagine if this homeowner had received an alert 30 minutes before this happened. Imagine if barriers automatically deployed around his property. Imagine if pumps kicked in without him lifting a finger. This isn't science fiction. These smart home gadgets exist right now, and I'm going to show you exactly how they would have prevented every single problem you're seeing in this real flood footage. Right there, pause the footage. Water just started seeping through this basement window, and in the next few seconds, this Los Angeles homeowner's life changes completely. This exact moment shows the fundamental problem with how we handle floods. By the time you see water, you're already losing the battle. Traditional flood warnings fail because they rely on water that's already moving. Emergency services send alerts when rivers overflow or when storm drains back up, but that water has been building underground for hours. Weather services track rainfall totals and issue warnings, but these systems can't tell you when groundwater will breach your specific property. The Los Angeles homeowner received zero advance notice despite living in an area with known drainage problems. Flash flood warnings went out to the entire region, but nothing targeted his street, his block, or his basement window. Here's what makes smart flood detection completely different. Instead of waiting for water to appear, these systems monitor what happens before flooding starts. Smart water leak detectors designed for flood prevention don't just sit in your basement waiting for water to reach them. You place these sensors around your property perimeter in crawl spaces near foundation walls and at the lowest points where water naturally collects. Companies like Flow by Moen and Finn manufacture sensors specifically for this outdoor monitoring, not just indoor leak detection. The real breakthrough technology uses soil moisture sensors buried around your foundation. These devices measure groundwater saturation levels in real time. When heavy rain overwhelms drainage systems, groundwater rises first, then surface water follows. The sensors detect this underground water movement 20 to 30 minutes before any flooding becomes visible above ground. They use capacitive sensing technology that measures electrical conductivity changes in soil as water content increases. When conductivity spikes beyond preset thresholds, the sensors trigger immediate alerts. These sensors connect directly to smartphone apps through Wi-Fi or cellular networks, but they do more than just send basic notifications. The apps integrate GPS-based weather data from services like Weather Underground and the National Weather Service. This integration creates hyper-local flood risk assessments. Your sensors know current soil saturation, incoming rainfall predictions, and historical flooding patterns for your exact location. The system calculates flood probability for your specific property, not just general regional warnings. When sensors detect rising groundwater, they automatically cross-reference this data with incoming weather forecasts. If rain continues and soil moisture keeps climbing, the app escalates alert levels. You receive the first notification when sensors detect unusual moisture increases. The second alert comes when moisture levels reach critical thresholds. The final warning triggers when the system predicts surface flooding within 30 minutes based on current saturation rates and rainfall intensity. This 30-minute window creates a cascade effect that changes everything about flood response. Instead of discovering water damage after it happens, you get enough time to activate protective systems before flooding starts. 30 minutes allows automated barriers to deploy around your property. It gives smart pumps time to begin preemptive drainage. It lets you move vehicles, secure valuable items, and implement emergency protocols while you still have clear access routes. The difference between reactive and proactive flood management shows clearly in the Los Angeles footage. This homeowner had no warning system, no advance notice, and no automated response. He discovered flooding when water entered his basement, leaving him with only damage control options. Smart detection systems would have alerted him while groundwater rose beneath his property before any surface water appeared. Early detection transforms panic into preparation because it gives you control over timing. You're not rushing around in rising water trying to save belongings. You're not calling emergency services while water pours through windows. Instead, you're implementing a planned response while conditions still allow safe movement and clear thinking. But detecting floods early only matters if you can actually do something with that warning time. Look at this footage again. The water completely overwhelms this Los Angeles property, rushing around the house like a river that changed course. This homeowner had no barriers, no protection, nothing to slow down the advancing flood. But even homeowners who prepare traditional defenses face the same devastating results. The Maxmaker video shows exactly what happens when manual flood barriers meet unexpected water volume. This homeowner built concrete barriers around his property and installed steel borders, specifically designed to redirect water flow. He spent time, money, and effort creating what looked like solid flood protection. The concrete barriers stood several inches high along vulnerable areas. The steel borders created channels meant to guide water away from the foundation. When the flash flood arrived, these carefully constructed defenses failed completely. The water volume exceeded every calculation. The barriers that seemed adequate during planning couldn't handle the actual force and speed of rushing floodwater. Water overwhelmed the concrete barriers, flowed over the steel borders, and entered the basement through the window despite all the manual preparation. Even well-prepared homeowners with traditional barriers face failure when flash floods exceed expectations because manual systems can't adapt or respond to changing conditions. Sandbags work only if you have enough of them, place them correctly, and stack them before water arrives. Concrete barriers protect against predictable water levels, but become useless when floods exceed their height. Steel channeling systems redirect normal water flow but create bottlenecks when overwhelmed by flash flood volumes. Manual barriers represent fixed defenses against unpredictable threats. Automated flood barriers deploy without human intervention when sensors detect rising water, creating responsive protection that adapts to actual conditions rather than predicted ones. Companies like Floodbreak manufacture barrier systems that connect directly to the same soil moisture sensors and water level detectors used for early flood warning. When these sensors register dangerous water levels, they send activation signals to barrier deployment systems. The barriers activate automatically, regardless of whether homeowners are present, awake, or aware that flooding has started. Inflatable flood barriers represent one of the most effective automated solutions available today. These systems store deflated barrier materials in underground compartments along property perimeters, driveways, and vulnerable entry points. When sensors trigger deployment, compressed air systems inflate the barriers within 3 to 5 minutes. The inflated barriers reach heights of 2 to 4 feet, depending on the system's specifications. Aquafence manufactures inflatable barriers that withstand water pressure up to several feet deep. The compressed air systems include backup power supplies that operate during electrical outages common in severe weather. The barriers inflate in sections, creating continuous protective walls around designated areas. Smart floodgates automatically close based on water level sensors, unlike manual steel barriers that require human operation. These gates install at driveways, walkways, and other property access points where traditional barriers would block normal use. The gates remain open during normal conditions, allowing vehicle and pedestrian traffic. When water level sensors detect flooding conditions, motors automatically close the gates and seal them against water intrusion. Tiger Dam manufactures automated gate systems that integrate with smart home networks, sending closure notifications to homeowner smartphones. Retractable flood walls emerge from driveways and property lines using hydraulic systems that lift protective barriers from underground storage positions. These walls store below ground level in weatherproof housings along property boundaries. When activated by sensor networks, hydraulic pumps raise the walls to predetermined heights within 5 to 10 minutes. The walls lock into position and create continuous barriers that redirect water flow away from protected areas. The response time difference changes everything about flood protection effectiveness. Manual sandbagging requires hours of physical labor, multiple people, and advance warning to complete before water arrives. Loading, transporting, and placing hundreds of sandbags around a property takes most homeowners 4 to 6 hours minimum. Automated barriers deploy in 5 to 10 minutes without requiring any human presence or physical effort. Automated barriers would have protected the Los Angeles property perimeter before water reached the house, creating a defensive boundary that redirected the rushing water away from vulnerable entry points. The basement window flooding shown in both videos could have been prevented entirely. But what happens when water still finds a way inside, despite perimeter protection? Watch how quickly water accumulates in this basement. Within minutes, the Los Angeles homeowner faces several inches of standing water despite his efforts to control the situation. The water enters through multiple points simultaneously: the basement window, foundation cracks, and floor drains backing up. He has no pumping system in place, no way to remove the water as it enters, leaving him completely reactive to the rising flood. Traditional sump pumps create this exact problem because they only activate when water reaches them, often too late for prevention. Standard sump pumps sit in basement pits waiting for water to accumulate before they start working. By the time water reaches the sump pit, flooding has already begun throughout the basement. The pump removes water from one location while water continues entering from multiple other points. This reactive approach means you're always fighting water that's already inside your home, rather than preventing it from accumulating in the first place. The Los Angeles homeowner had no pumping system ready when water started entering through multiple entry points, leaving him with buckets and manual removal methods that couldn't match the incoming water volume. Without any mechanical water removal, he watched helplessly as water levels rose faster than he could bail it out. Manual removal becomes impossible during heavy flooding because incoming water exceeds what any person can physically remove. Smart sump pump systems activate based on external sensor data rather than internal water levels, creating proactive water removal before flooding starts. These systems connect to the same soil moisture sensors and water detection networks used for early flood warnings. When sensors detect rising groundwater or predict imminent flooding, smart pumps begin operating before water enters the basement. Wayne, Zoller, and Liberty Pumps manufacture smart sump pumps that receive activation signals from external sensor networks. The pumps start removing water from drainage systems and foundation areas before visible flooding occurs. These pumps connect to the same sensor network as the detection systems, creating a coordinated response throughout your entire property. Soil moisture sensors communicate directly with smart pump controllers through Wi-Fi or cellular connections. When moisture levels reach predetermined thresholds, the system automatically activates all connected pumps simultaneously. This coordination means your entire property responds to flood threats as one integrated system, rather than individual components operating independently. Backup power systems and battery operation keep pumps running during power outages common in floods. Smart sump pumps include battery backup systems rated for 8 to 12 hours of continuous operation. These backup systems automatically engage when electrical power fails, maintaining pump operation throughout extended outages. Battery systems recharge automatically when power returns, ensuring readiness for subsequent flood events. Smart pumps can be staged at multiple locations: basement, crawl spaces, and exterior drainage points, providing comprehensive water removal coverage. Instead of relying on one basement pump, smart systems deploy multiple units throughout vulnerable areas. Exterior pumps remove water from foundation drains and landscaping areas before it reaches the house. Crawl space pumps handle water entering through ventilation areas and floor joints. Basement pumps provide final protection against any water that penetrates other defenses. The monitoring capability tracks pump performance and alerts homeowners to potential failures through smartphone notifications. Smart pumps continuously monitor motor current, flow rates, and operating cycles. The system detects pump malfunctions, power supply problems, and impeller clogs before complete failure occurs. Homeowners receive real-time alerts about pump status, water levels, and system performance regardless of their location. Flow rates determine how much water these pumps can remove per hour. Standard smart pumps handle 2,000 to 4,000 gallons per hour, while high-capacity models remove up to 8,000 gallons hourly. Multiple pumps operating simultaneously multiply this removal capacity. Coordinated smart pumping would have prevented basement water accumulation in the Los Angeles case by removing water from foundation areas before it entered through the basement window. The system would have activated when sensors detected rising groundwater, creating drainage around the foundation before surface water reached vulnerable entry points. But removing contaminated floodwater creates health hazards that most homeowners never consider. Look at this murky, debris-filled water rushing through the Los Angeles property. You can see leaves, dirt, and unidentifiable debris swirling in the brown liquid. But what's really in there that you can't see? What invisible threats is this homeowner walking through without any protection? Floodwater contains sewage, chemicals, bacteria, and toxins that are invisible but deadly to anyone exposed. When storm systems overwhelm municipal drainage, raw sewage mixes directly with floodwater. Gasoline and motor oil wash off streets and parking lots into the flood stream. Industrial chemicals leak from storage facilities and mix with residential cleaning products floating out of flooded basements. Agricultural runoff brings pesticides and fertilizers into urban flood areas. All of these contaminants create a toxic soup that looks like ordinary dirty water. The bacteria content alone poses serious health risks. E. coli bacteria from sewage overflow causes severe gastrointestinal illness within hours of exposure. Vibrio bacteria thrives in warm floodwater and enters the body through open wounds or cuts. Leptospirosis bacteria spreads through animal urine contamination and causes kidney damage, liver failure, and potentially death. These bacteria multiply rapidly in stagnant floodwater, reaching dangerous concentration levels within hours. Watch the Los Angeles homeowner wade through this contaminated water without any protective equipment. He steps directly into water that potentially contains all these invisible threats. His exposed skin contacts bacteria-laden liquid. He breathes air contaminated with sewage vapors. He risks infection through any small cuts or scrapes on his hands and feet. This homeowner has no idea what health risks he faces simply by walking through his flooded property. Smart water quality sensors detect contamination levels in real time, providing immediate health risk assessments that manual testing cannot match. Companies like Aquatrol and YSI manufacture sensors specifically designed for emergency water quality monitoring. These devices test for multiple contamination indicators simultaneously rather than requiring separate tests for each potential threat. The sensors measure bacterial counts, chemical concentrations, and sewage indicator levels automatically every few minutes. The sensors test for E. coli, chemical pollutants, and sewage indicators automatically using advanced detection technology. E. coli sensors use fluorescence-based detection that identifies bacterial proteins within minutes rather than the hours required for laboratory cultures. Chemical sensors detect petroleum products, heavy metals, and industrial solvents using spectroscopic analysis. Sewage indicator testing measures ammonia levels and coliform bacteria, counts that signal human waste contamination. Smartphone integration provides immediate contamination alerts and safety recommendations based on real-time sensor data. The connected apps display contamination levels using color-coded risk scales. Green indicates safe water contact. Yellow warns of moderate contamination requiring protective equipment. Red signals dangerous contamination levels requiring immediate evacuation. The apps provide specific safety instructions for each contamination level, including required protective gear and exposure time limits. Smart ventilation systems activate to prevent contaminated air from entering the home when sensors detect airborne contaminants from floodwater. These systems monitor air quality for sewage gases, chemical vapors, and bacterial aerosols. When contamination reaches dangerous levels, the ventilation systems automatically switch to recirculation mode and activate air filtration. HEPA filters remove bacterial particles while activated carbon filters absorb chemical vapors and sewage gases. UV sterilization systems treat water automatically when contamination is detected, providing on-site water purification without manual intervention. These systems install at water entry points and activate when quality sensors detect bacterial contamination. UVC light destroys bacteria, viruses, and parasites by disrupting their DNA structure. The sterilization process takes seconds and requires no chemical additives that could create additional contamination. Contamination sensors would have warned the Los Angeles homeowner about health risks and activated protective measures before he entered the floodwater. Real-time bacterial monitoring would have detected sewage contamination immediately. Chemical sensors would have identified petroleum and industrial pollutants. The smartphone alerts would have recommended protective equipment and exposure limitations. Automatic ventilation systems would have prevented contaminated air from entering his home. However, the ultimate solution addresses water flow at its source before contamination becomes a health threat. Here's where everything went wrong. Watch this moment when water started pooling around the Los Angeles property. You can see how the existing drainage simply couldn't handle the sudden volume. Water collects in low spots, overwhelms storm drains, and creates the perfect conditions for basement flooding. The property's drainage system worked fine during normal rainfall, but flash flood conditions revealed its complete inadequacy. The Maxmaker video shows this same failure pattern from a different angle. His basement window flooded because traditional drainage couldn't handle the volume of water flowing toward his foundation. He had standard gutters, downspouts, and yard drainage that functioned perfectly during typical storms. When the flash flood arrived, these conventional systems became bottlenecks rather than solutions. Water backed up, overflowed, and found the path of least resistance directly into his basement. Even well-designed manual drainage systems become overwhelmed during unexpected flash floods because they operate on fixed capacity assumptions. Engineers design drainage based on historical rainfall data and predicted storm intensities. These calculations work for normal weather patterns but fail when climate change creates unprecedented rainfall volumes. Fixed capacity systems cannot adapt when conditions exceed their design parameters. Smart drainage systems with automated valves solve this capacity problem by adjusting water flow in real time based on sensor data. These valves connect to the same water flow sensors used throughout smart flood defense networks. When sensors detect rising water levels, automated valves open additional drainage channels or redirect water flow to prevent bottlenecks. Hunter and Rainbird manufacture smart irrigation valves that adapt for flood drainage applications. The valves respond within seconds to sensor triggers, creating dynamic drainage capacity that changes based on actual conditions rather than predicted ones. Underground storage tanks collect excess water temporarily when surface drainage reaches capacity limits. Companies like Stormtech and Cultec manufacture modular underground storage systems that install beneath driveways, lawns, and landscaping areas. These tanks hold thousands of gallons of excess water during peak flooding, then release it slowly through controlled outlets when surface water levels drop. The tanks include sensors that monitor water levels and automatically regulate inflow and outflow rates. Smart controls prevent the tanks from overflowing while maximizing their storage capacity during flood events. Smart irrigation integration preemptively drains soil moisture when floods are predicted, creating additional absorption capacity before storms arrive. Rachio's smart irrigation controllers connect to weather forecasting services and soil moisture sensors throughout the property. When flood predictions indicate heavy rainfall within 24 to 48 hours, the irrigation systems automatically increase watering schedules to draw moisture from soil. This preemptive drainage creates space for incoming rainwater and reduces surface runoff during actual flood events. Automated gutter systems with smart downspout controls redirect water flow dynamically based on real-time water accumulation patterns. Traditional gutters dump water in fixed locations regardless of ground saturation or drainage capacity. Smart downspout systems include motorized diverters that redirect water flow away from saturated areas toward locations with better drainage capacity. These systems monitor ground moisture levels around each downspout location and automatically adjust water distribution to prevent pooling. The coordination between all smart systems creates comprehensive flood management that addresses water flow from every angle. Sensors detect rising groundwater and activate drainage valves. Underground storage tanks collect excess surface water while smart irrigation systems create soil absorption capacity. Automated gutters redirect water away from vulnerable areas while smart pumps remove any accumulated water. This coordination operates automatically without requiring human intervention or decision-making during emergency conditions. Intelligent drainage would have diverted water away from both the Los Angeles property and Max Maker's basement window by creating multiple pathways for water flow and storage. The automated valves would have opened additional drainage channels when sensors detected rising water levels. Underground storage would have collected excess water before it reached foundation areas. Smart downspouts would have redirected water away from basement windows toward better drainage locations, but individual smart systems only reach their full potential when integrated into one complete defense network. Picture this side-by-side comparison. On the left, you see the chaotic Los Angeles flood footage with water rushing uncontrolled through the property, overwhelming the helpless homeowner. On the right, imagine a computer simulation of that exact same storm hitting a property equipped with smart flood defenses. The simulation shows sensors detecting rising groundwater 30 minutes early, barriers automatically deploying around the perimeter, pumps activating before water reaches the foundation, and drainage systems redirecting flow away from vulnerable areas. The difference transforms disaster into management. All these individual smart technologies connect into one coordinated defense network through integrated platforms like Control4, Hubitat, and SmartThings. These central hubs manage every component as a unified system rather than separate devices operating independently. SmartThings offers versatile automation capabilities that create custom responses when flood conditions develop. Hubitat emphasizes local processing, ensuring flood protection systems continue functioning even when internet connections fail during emergencies. Control4 provides professional-grade integration for larger properties, requiring complex coordination between multiple defense systems. The total cost and complexity might seem overwhelming when you consider everything together. A basic smart flood setup with water sensors and a smart hub costs several $100s. Comprehensive systems including automated barriers, smart sump pumps, and professional monitoring reach several $1,000s depending on property size and complexity requirements. However, FEMA reports that average flood damage costs exceed $10,000 per incident, making prevention systems financially logical investments. The central control system manages sensors, barriers, pumps, and drainage as one integrated unit through continuous communication between all components. When soil moisture sensors detect rising groundwater, they simultaneously trigger barrier deployment, pump activation, and drainage valve adjustments. The system coordinates timing so barriers deploy before water reaches them, while pumps begin removing water from foundation areas, and drainage systems create additional flow capacity. This coordination happens automatically without requiring human intervention during emergency conditions. Machine learning improves the system's response over time by analyzing historical weather patterns, water flow data, and sensor readings to optimize performance. The system learns seasonal flooding patterns specific to your property location. It identifies which sensor combinations predict actual flooding versus false alarms. The machine learning algorithms adjust activation thresholds based on successful flood prevention events and refine timing coordination between different system components. This continuous improvement makes the system more accurate and effective with each flood season. The smartphone dashboard gives homeowners complete visibility and control during flood events through real-time monitoring interfaces. You see live sensor readings from around your property, current status of all barriers and pumps, and predicted flood timeline based on weather integration. The dashboard allows manual override of automated systems if conditions require different responses than program defaults. Alert notifications provide specific information about which systems activated and why, eliminating guesswork during emergency situations. Professional monitoring services take over during emergencies when homeowners are away or unable to respond to system alerts. These 24-hour monitoring centers receive the same sensor data and system alerts that appear on your smartphone. Trained operators can remotely activate barriers, adjust pump operations, and coordinate with local emergency services if flooding exceeds system capacity. This monitoring ensures appropriate responses happen even when homeowners travel or face communication disruptions during severe weather. Insurance companies recognize smart flood prevention systems and potentially reduce premiums for homeowners who install comprehensive protection. The specific reductions depend on your insurance provider and system extent, but potential savings help offset initial investment costs. Contacting insurance providers about available discounts provides accurate premium reduction information for your specific situation. This complete system would have transformed the Los Angeles disaster into a managed, controlled event where water never entered the basement because barriers redirected flow while pumps removed foundation moisture before surface flooding began. The homeowner would have received 30-minute advance warning, watched automated defenses deploy successfully, and monitored the entire event safely from inside his protected home. Climate change makes these systems essential rather than optional as flood frequency and severity increase beyond historical patterns. Climate change creates more frequent and severe floods through rising sea levels and heavier rainfall patterns that exceed historical norms. The Los Angeles homeowner represents millions facing this reality unprepared. You have two choices: remain a reactive victim who discovers flooding when water enters your home, or become a proactive protector using smart technology to defend your property and family. Start with one smart water detection device, add automated barriers next, build your smart pump system gradually. Each component strengthens your defense network. The 30-minute warning window, automated barriers, and coordinated pumping systems exist today, waiting for homeowners ready to take control of their flood risk.